asked Ann to talk a little bit, because as everyone here knows, I think, Ann is an astronomer and has been at the University of Hawaii all these many years, and was the president of the American Astronomical, sorry, and not astrological, maybe that too, I don't know, but Astronomical Association. And so I said, wouldn't it be fun to ask Ann to talk a little bit about the realities of Mars? I do know from reading about The Martian in the book and the movie that the author has been given great credit by NASA and others about his research. And he is a space nut, basically. He's not an astronaut and not trained in that, but he's always been fascinated by it. So I thought I would turn it over to Ann and let her tell us
Well, I'm just going to give
the realities of this.
You're still up. But
I know, but I'm going to sit down.
I'm just going to give you some background about Mars. It's called the red planet, and the reason it's red is because it has iron oxide on the surface, so that makes it red. It is 1.5 times as far from the sun as the Earth is. And so it takes it a lot longer to go around the sun. In fact, it's like 1.9 years to go around the sun. But it's similar to the sun in the fact that it's tilted on its axis like we are. We're tilted by 23.5 degrees. Mars is more like 25 degrees, but it's because we're tilted on our axis that we have seasons. So there's seasons on Mars too, but because its period is almost 2 years, its seasons are all, each one is going to be more like 6 months. But they're not going to be very nice. The atmosphere of Mars is about 1% of the Earth's atmosphere. And it's carbon dioxide, for heaven's sakes. And so this is not very nice. It turns out that something like 1/2 to 3% of Mars is water. That sounds good, except the water is all bound up in compounds, which is why this guy on Mars has to get his water by these dangerous things that he has to do. So the day on Mars is 24 hours and 37 minutes. So that's like us. It's years, a couple of years, and it's tilted on its axis like us. But it is only 11% of the Earth's mass. So the gravity is nothing like what we're used to. You can just bound around on Mars. The terrain, unlike what you may have seen yesterday in Darby's lecture, is, well, there's this enormous basin that covers about 1/2 of the planet called the Borealis Basin. It covers actually 40% of the planet. So that's probably happened with an impact. There's a canyon called Valles Marineris, which is the largest canyon in the solar system, in spite of the fact that this is a fairly small planet. It also has the largest mountain in the solar system. It's called Olympus Mons, Mount Olympus. And in astronomy textbooks, they will show this picture of Mount Olympus. And then they show Mauna Kea and Mauna Loa and the Big Island. And they go down into the sea. They show Everest, it's those little features we have are just tiny compared to Olympus Mons. So it has a lot of similarities to the Earth, but it has these really important differences with the Earth. It also has 2 moons. For us, we only have 1. They have 2 moons, but they're not very big, and they're irregular shaped. They're not spheres. So they think that they may have been captured from the asteroid belt, which is between Mars and Jupiter primarily. So this thin atmosphere does cause significant problems for manned expeditions to Mars. Plus, the water issue. We first sent an explorer to Mars in 1965. That was Mariner 4. Now we have 7 things that are orbiting around Mars. And as she said in her lecture yesterday, these orbiters really can look down and see much more detail than we've ever been able to see before. So that's the background of Mars. And this poor guy, oh, the other thing is, it takes a long time to get there, or an enormous amount of energy to get there, because if you go when we're the closest, and of course, we go around once, and well, we're going around once, Mars is only halfway around. So what NASA usually does is to take advantage of the Earth's orbital speed. And so we would send something off to Mars at the right time to intersect with Mars when it's there, although it's here when it's starting. So that takes a long time. And the problem with it taking a long time is there's a lot of radiation from the sun. And this radiation is gonna kill them. But if you put enough iron to shield them, the spacecraft is going to be so heavy it'll never get off the ground. And if you try to do it at the time, you know, we have a solar cycle where there's a lot of activity and then it goes up and increases and then it kind of falls off every 11 years. So you want to send them as the cycle is going down before it starts going back up, to protect from the radiation. But nonetheless, that is a serious problem, and you have to be an exceptionally brave astronaut to do this. You know, our astronaut who was up in the space station for 100 days, yeah, Scott Kelly, when he came back, he was 2 inches shorter. His skin was so sensitive, you know, he just could hardly touch it because it would tickle and sting. So that's going to be a hard trip.